Hello everyone, welcome back to ACE Exams. This is Maath Alabdali speaking from ACE Exams. Today I'm going to be explaining part 2 of topic 1, which is the atomic structure and the periodic table. If you haven't watched my part 1 yet, I'm going to place the link in the description. You can watch it. I advise you to watch part 1 before watching this. So, shells, subshells, and orbitals. Now, an electron surrounds the nucleus by an atom, and then they are arranged in orbitals, subshells, and shells. There are different subshells. So there's S subshell, P subshell, D subshell, and F subshell. And in the S subshell, there's a total number of 1 orbital. P subshell, there's 3, D is 5, and F is 7. Now, in each orbital, it can hold up a maximum of 2 electrons. So you could find the total number of electrons by multiplying 2 with the number of orbitals in that shell. So for example, in the S orbital, there's only one, in the S subshell, sorry, there's only one orbital, so 1 times 2 is 2. 3 times 2 is 6. In the D orbital, in the D subshell, 5 times 2 is 10. In the F subshell, 7 times 2 is 14. The proper definition of orbital that you have to know from as an A-level student is the region around a nucleus where there is a high probability of finding an electron. This is like a proper definition. If you write this in the exam, I can guarantee you now that you're going to get the definition right. So an orbital, it can hold up a maximum of 2 electrons, as I mentioned earlier, and then it has to be in opposite spins. So if one is pointing upward, the other one has to be pointing downward, and I'm going to show you an example in the coming slides. So electrons, they exist in atoms, they exist in energy levels. These energy levels, we call them quantum shells. So as the number of shells increases, then the energy and the distance from the nucleus increases as well. Yeah, that's it. So the maximum electrons per shell, in the first shell it is 2 electrons, second shell is 8, third shell 18, and fourth shell 32. I'm going to explain to you why in a sec. So if you look in here, this is the first subshell. This is the first shell. In the first shell, there's only one, like it's just one S, and then we said that a subshell, it can hold a total number of electrons of 2. So that's why in the first shell it's only 2 electrons. Second shell is 2 plus 6, which is 8. In the third shell is 2 plus 6 plus 10. This might not be clear, but it's 3D. So 2 plus 6 plus 10, which is 18. In the fourth shell, it's 2 plus 6 plus 10 plus 14, which is 32. I'm going to explain to you why the 3D of the 4S overlaps the 3D now. Okay, so if you look here, that is how the electron configuration is done. So first is going to be 1S, which has a total number of 2 electrons, then 2S, which has a total number of 2 electrons, then 2P, then 3S, then 3P, and then 4S, then 3D, then 4P, then 5S, then 4D, then 5P, then 6S, and then this is just, it goes further on. But for A-level, I think you have to know up to 5S. So this is gonna link to ionizing energy, which I'm gonna explain in a few slides. Just bear with me. Now, so this is the shapes of the orbital. We have the S orbital and then P orbital. S orbital is basically a spherical shape, and it occurs in every principal energy level. So in every shell, you'll find an S orbital, and it's always gonna be a spherical shape. In the exam, they might ask you to draw the S orbital, which is basically a spherical shape with X, Y, and Z. What do you call it? X, Y, and Z axes. Axes or axes, whatever you call it. The P orbital is a dumbbell shape, so it's either in a straight, like literally a straight line, like that, but you have to draw it in a dumbbell shape, or it can be pointed to the left or to the right. So this is some exam style questions. Define orbital. I said earlier that orbital is the region around the nucleus where there is a high probability of finding an electron. This is literally the proper definition. Region around the nucleus where there's a high probability of finding an electron. Yep. Now, state the maximum number of, sorry, that should be electrons. Give me a second. So state the maximum number of electrons that's going to occupy S, P, and D subshell. So in the S subshell, it's going to be a total of 2 electrons. It might be not clear, but this is obvious. S is 2 electrons, P is 6, and D is 10. If you don't understand why, I suggest you go back and then listen to the recording again. State the maximum number of electrons that can occupy each of the first quantum shell. So it's 2, then 8, then 18, and then 32, which I explained why earlier, if you don't understand it. So you can go back if you want. Electron configuration. This is where it slightly gets interesting. Now, in electron configuration, we have to use the box notation, or literally the normal notation, which is the 1s, 2s, 2p6, yeah, and then so on. So box notation for an electron configuration of atoms allow the electron in each atomic orbital to be seen more clearly. So this is the full orbital of silicon, and it has a total number of electrons of 14. So 1s, it has 1s holds a maximum of 2 electrons with opposite spin, and that is what I was explaining earlier. So 1 is pointing to upward and 1 is pointing downward, if you can see here. So 14, then you start filling 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you have 14 electrons, so you put 2 in here, 1, 2, and then in here you put 1 in here and then 1 in here. You don't put 1 here, you don't put 1 and 2 in here, because electrons like to be left alone. It's like, imagine yourself going to a bus, and then you see that there are like 5 seats, 4 of them, each person is sitting, like one person is sitting on 4 seats, and then there's a space, I don't know how to explain it, there's a space next to each person in the 4 seats, but then there's the 5th seat which is totally left alone. You'd obviously go to the 5th seat, which is like you want to stay alone, basically. Just remember it like that. Yeah, if you remember it, yeah, just remember that. So this is the shorthand notation. Now we know that neon, it has a total number of electrons of 10. So you could literally write 10, you could literally write neon in square brackets, and then write 3s2 and 3p2. If you see that in the exam, don't get scared. It's just a shorthand notation. Now this is an electron configuration all the way from hydrogen to zinc. So from 1 electron to 30 electron. Now I'm going to mention this is very important, and since it is an exception, it's likely that it's going to come up in the exam. Chromium and copper. Now chromium, it's going to have, at the end, it's going to have an electron configuration of 4s1 and 3d5. And then copper, it's going to have a total number of electron of 4s, at the end it's going to be 4s1 and 3d10. So it's not going to be 4s2 3d9. So these two. Now if you ask me why, the answer is going to be quantum mechanics. So it's something to do with physics, which I'm not going to touch on in this video. where it gets trickier. So the ionizing energy is the amount of energy of an element, is the amount of energy needed to remove one electron from each atom in a mole of atoms of an element in a gaseous state. And the equation, they might ask you to write the equation of the ionizing energy of a specific substance in the first ionizing energy. So it's just M, and you have to write the symbol, which is gas. They mark you for it. Arrow M plus E minus. And one thing that I have to say is that many students, they forget to write the symbols of the like the equation, which is very important. In the exam question, it might be 2 marks, and then 1 mark you'd given for the equation and 1 mark for the symbols. Now, let's say if they ask you to define the ionizing energy, the second ionizing energy, which is defined as the energy per mole, which is M plus gas arrow M2 plus E minus. Now, if they ask you to define the second ionizing energy, you just have to say that it's the amount of energy we needed to remove 2 electrons from each atom in a mole of atoms of an element in the gaseous state. And yeah, so on for successive ionizing energy. So if they ask you for the third, just say the amount of energy needed to remove the third electron from each atom in a mole of atom of an element in a gaseous state. The ionizing energy, they are always endothermic. So why? Because we are removing an electron, which always takes an energy, and that is why it is endothermic. Okay, so over here we get to the trends of the ionizing energy, the first ionizing energy. So in the first ionizing energy, it decreases going down the group because the energy of the subshell from which the electron is removed increases, and then the amount of shielding increases. We also have to know that the number of protons also increases, but it has a very less significant effect. Now that is across a group. What if they tell you what is the trend across the period? If they're asking the exam, what's the trend across the period? So the ionizing energy increases across the period. It's opposite to the group. Why? Because the energy of the subshell from which the electron is removed decreases. And yeah, it's literally the opposite. Now I'm going to explain shielding before I explain the effect. So shielding is the electron repulsion. It exists between 2 electrons in the same orbital and between electrons in different orbitals. So electrons, they are both negatively, like the electrons are negatively charged, they love to repel each other. Because negative and negative repel. Now, evidence for subshell. The first ionizing energy for aluminium is lower than it is for magnesium because the 3p electron is removed from aluminium is higher in energy than the 3s electron removed from magnesium and has a greater shielding. So in the exam they must ask you why aluminium is lower than magnesium. It's because the 3p electron removed from aluminium is higher in energy. That is 1 mark. And then it has a greater shielding. It might be 2 marks question. Periodicity is where we talked about melting and boiling temperature, and we're going to talk about the atomic radius. So melting and boiling temperature, these vary across a period depending on the types of structure and bonding present. So metal have a metallic bonding and a giant lattice structure. Boron, carbon and silicon, they have a covalent bonding and a giant lattice structure. Noble gases in group 0 and monoatomic, they exist as individual atoms, and other non-metals have a covalent bonding and simple molecular structure. So in the exam they might give you this graph and then they'll be like, oh, why the melting point or the boiling point increases and then it decreases again, and then you have to explain the bonding in sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. And this is not only for the period 3, but this can also be possible for period 2 as well. Now, atomic radius. Atomic radius of an element is the distance from the center of the nucleus to the boundary of the electron cloud. So it shows periodicity. So atomic radius, it decreases across the period and increases from one period to the next. Um, so what I mean in here is that it decreases across the period. So in the period it decreases, but then it increases from like in the group across the groups, and it's shown here in the graph. There's a negligible increase in shielding across the period, but the nuclear charge increases. This increases the force of attraction between the nucleus and other electrons. So yeah, this is basically with topic 1. We are done with topic 1. If I have missed anything, can you please comment in the comment? Yeah, just comment under the video. Before I finish, I'm just gonna mention a few exam style questions that, like, just for practice. So, explain why the first ionizing energy of krypton is higher than selenium. So, the answer is that krypton has a lower atomic radius than selenium. It has the same shielding though. The atomic charge of krypton is higher than the atomic charge of selenium, so lots of energy is required to break the bond. Therefore, krypton has a higher ionizing energy than selenium. Now, in the exam, I advise you to mention all the three: atomic radius, shielding, and atomic charge. Even though it is, like, let's say it is only one mark question, I still advise you to mention all the 3 points, because you can, like, let's say you mess up in the first point, you can still get marks for the second and the third point. So thank you very much for watching. Thank you for listening. See you in the next video. Please stay safe and subscribe. If you like the video, please like the video, and bye.